Good morning, everyone. We can start now the webinar. So welcome to the Renewable Wave of Projects. I'm Serena Scotton, and I'm working at the European Heat Pump Association, which is the organizer of this event. As you may already know, the Renewable Wave of Projects is a webinar and is a part of a series called Projects Online Talks, which will guide us during this summer and maybe beginning of autumn. We will organize other webinars dedicated with a focus on heat pumps and projects. As you can see here in this slide, the next event will be in 1 month and it will be about heat pumps and district heating. Then we will continue with other events with different thematics, but always with a focus on innovative and interesting projects with a high level of replicability. If you're interested in this activity, you can follow EHPA on the website or on the Twitter account, and in there you will find all the information and registration links for the upcoming events. Coming back to today's event, as you know, this webinar is dedicated to the renewables applied in projects. Today we will have 4 projects which are applying renewable energies in different sectors. So we will start with the GeoAtlantic, which is an Interreg funded project which aim at the promotion of sustainability and geothermal energy in the Atlantic area. Then we will have SunHorizon, which is an Horizon 2020 project with a focus to innovative sun-coupled heat pumps applied in the residential and tertiary sectors. Then we will proceed with a project developed by the Politecnico di Torino in Italy with a focus on energy tunnels and as an opportunity for development for the urban areas. Then my colleague then will present us an Horizon 2020 funded project that is the Secretariat of the Renewable Heating and Cooling Platform, and an EHPA initiative that is the Research and Innovation Committee. As you can see, we are keeping the Q&A session at the end of the event. So if you have any questions during the webinar, please use the questions box here, and you can send directly to me your question. Please indicate the name of the speakers which you are referring to. And then once we have collected all the questions, we will proceed with 20-30 minutes at the end of the webinar. Some few information, like technical information. So this webinar will be recorded. Please do not turn on your camera. We will record only the screen with the presentations and the speakers' speeches. We will share with you all the presentations plus the video tomorrow via email. And these are the technical part. So I think we have covered all. So we can officially start the webinar, and we can start with the first presentation and with our first speaker, that is Eduardo. So let me give you the keyboard and mouse. So Eduardo, you can unmute yourself, and please, the floor is yours.
Okay, thank you, Serena. Good morning to all. This is Eduardo Rodriguez, the Industry and Sustainable Area Manager from EnergyLab. And now I'm going to talk to you about the GeoAtlantic project, which is focused on geothermal energy promotion. Well, I divided the presentation into many parts. First, a very short presentation of EnergyLab. I think it is important to explain who we are to understand more deeply our contribution to this project. And the last and more important, the challenges of the GeoAtlantic project and some highlighted results. So what is EnergyLab? We are a private technology center that specializes in energy efficiency and sustainability who set up on 2008. Our mission is to improve the competitiveness of business fabric through innovative projects aimed to enhancing the energy performance and reducing the environmental impacts of their activities. The governing body of our center is based on a board which includes both public and private entities such as Inditex, Philips, Naturgy, and all universities of Galicia. We work in 4 main research lines: sustainable building, industry, bioenergy, and mobility. But I only want to highlight some work lines of industry area, such as data analytics for advanced energy and waste management, waste heat recovery, and circular economy, and some outlines of sustainability building areas, such as near zero energy building, energy storage system, thermal and electric, renewable district heating system, and optimization of geothermal system, where we try to improve energy performance of heating, cooling, and domestic hot water production system based on heat pump technology by several lines of work. So this was only a short EnergyLab presentation that I think is important to consider to understand our activities into the GeoAtlantic project like a tech partner. Well, as I said, we are one of the tech partners of the project led by the Ourense Council. This is the reason why we show our tech point of view of project. But first, it's important to know what is the Atlantic Area Program and its priorities. This will be useful to locate a project on the European energy strategies. Interreg Atlantic Area Program supports transnational cooperation projects in 36 Atlantic regions in 5 countries: France, Ireland, Portugal, Spain, and United Kingdom. It is part of the European Union Economic, Social, and Territorial Cohesion Policy. The general objective is to implement solutions to respond to regional challenges in the field of innovation, resource efficiency, and environmental and cultural assets, supported regional development and sustainable growth. The program has 4 priorities, but we only focus on number 2, promote resource and efficiency. Now let me introduce you the project. The GeoAtlantic project has been approved in May 2017 with a budget of 20.8 million euros, of which 75% will be financing by the European Regional Development Fund. Its execution period is 36 months between September 2017 and August 2020, but for the coronavirus pandemic, it will be extended to February 2021, 44 months on total. Well, about the partnership, the project has representation in all countries of Atlantic area: Spain, Portugal, UK, France, and Ireland, adding an exception. In this case, Belgium, where the project has an important partner, EHPA. Okay, in this slide, you can I showed you the location of the 12 main partners of the project. And what is the main objective of GeoAtlantic? Well, it is to promote and disseminate geothermal energy as a tool to help reduce greenhouse gases in Europe, which is a priority objective in the European Union. And now, this slide shows you the project work plan. Work package 1, coordination; 2, communication; 3, capitalization; 4, energy bench; 5, energy capacity; 6, energy innovation and business; and 7, energy location action. These are the expected results of the project, and if I'm right, at the moment we have reached almost all. I want to highlight that the territories who have improved their local energy policy are Bordeaux in France, Ourense in Galicia, and Oban in Scotland. Well, and now I want to introduce you the most interesting results developed on the tech work packages, in this case 4, 5, 6, and 7. About work package 4, action 1 and 2, under the leadership of Oporto University, Each GeoAtlantic project partner compiled information about the practice of the utilization of the geothermal energy system in the regions. And as a main conclusion, it was a common problem, institutional and regulatory barriers. What did we do? To develop an interactive tool reference to boost geothermal energy that now it hosts 136 files. Another interesting task on Work Package 4 was mapping the geothermal potential with exploration methodology. In this case, our colleague from ITER, Technological and Renewable Energy Center of Tenerife, are studying the geothermal potential in 3 territories: Canary Island and Azores, because they are in a volcano area, and Ourense, that is a thermal spring water city with a big geothermal potential to explore. What are they doing? They are analyzing the soil gas radon and CO2 and H2O efflux in predefined places where geothermal potential is expected to exist. Also, they are analyzing geochemistry and hydrogeochemistry studies, all of these to calculate the geothermal potential in selected places. I'm sorry for not explaining in more detail the methodology process, but I am not an expert in this topic. But the important thing to know is that there is a very close relationship between all measurements and the high or medium enthalpy potential in deep. Here you can see some results from Ourense studies about hydrogen, some results from Ourense studies about helium, and in this case, about radon. Now this slide shows you the results from Azores studies, in this case about CO2 efflux in Tercera Island. As I said, all these measurements are related to high temperature in deep. Now, finally related to this Work Package 4, to say that the studies for geothermal potential mapping are still in progress and the next results will come soon. Well, about next Work Package 5, energy capacity, is aimed to develop of those skills necessary for promotion of energy transition in local communities focused on the key stakeholders that can facilitate the energy model transition. So what did we do? Under the leadership of Cork Institute of Technology, each territory elaborated training action for capacity building at local ecosystem aimed at training the different agents related to local ecosystem. Which ones? Decision makers and technicians from local administration, energy prescribers, neighborhood association, energy service providers, and SMEs and potential prosumers. This slide shows you some examples of key training for capacity building in geothermal energy that were made by each territory, and this is the reason why the training material is focused on geothermal resource of each region. Also to say that in most cases, the training material includes didactic videos. Well, these are some pictures of training events that, if I'm right, we're training 250 person total, taking account all the target groups. But in Work Package 2 and Work Package 3, communication and capitalization, we reach 1,500 citizens. Well, now I'm going to show you some important results on Work Package 6, energy innovation and business. One of them was the identification technologies with potential for Atlantic area. With the collaboration of all partners, EnergyLab identified research results and technology which are already tested, but not yet introduced in Atlantic area energy market. Obviously, the geothermal energy potential is different in each region because the geothermal resource depends on the hydrological feature of the subsoil. In the same way, to boost the geothermal sector in Atlantic area, within this work package, we are creating alliances and links with research centers and technological providers to facilitate the transfer to the market. The first step of this action was to elaborate a guide that describes general and specific concepts related to technological transfer and include some good practice cases about geothermal installation from all partner regions. This guide includes some successful geothermal facilities which we analyzed during the project. One of these is the Kansas Mine water heat pump system in Exeter. Other successful geothermal facility in the Fano building in Aveiro University. And another one in Bordeaux, a district heating that connects 8 public buildings with a 120 megawatts per hour power consumption. There are more interesting cases of success in this document, which is available in the website of the project. Well, and last thing about the work package 6, if coronavirus allows us, we will visit and study the geothermal power plant in Azores, but at the moment it is unknown. And also, and finally, the last work package of the project, local action, is focused on 2 main actions. First, technical support group for the promotion of local energy plans, and the second, implementation and monitoring of geothermal pilot projects. About the first action, tech partners like University of Porto or us, we are giving technical support to local partners who are building the geothermal facility pilot. And about the second one, local partners like Ourense Council or Asociação de Municipios da Cova da Beira are building their pilot geothermal projects in their cities. Let me show you the progress of these pilot facilities. In Cova da Beira case, the slide that I'm showing, the pilot consists on replacing the natural gas boiler of the Fontesana Spa Center with a ground-source heat pump which used directly the thermal spring water in open loop to produce heating and cooling simultaneously. And the last pilot demonstration I want to show you today is in the Botanical building in Ourense City. The complex is composed by 2 main buildings. First, a small office which now is heated and cooled by a 8 kilowatts power ground-source heat pump. And the second one, a greenhouse where the geothermal facility pilot is going to heat and cool the plant space to improve their growing. In this moment, the technicians are doing the thermal response test, TRT, which result could solve some issues like upgrading the current facility or building a new one, location of the technical room and wells, and energy power demand. In the next week, we will have important advances. So that's all from me. I hope you could find some interesting results of the GeoAtlantic project, which is still in progress and it will finish on February 2021. And here I show you my contact email if you need to clarify any doubt. Thank you for your attention.
Thank you very much, Eduardo, for your presentation. I see that some of the participants raised their hands. Please use the questions box. If you have any comments or requests, please use that tool. Now, let's proceed with Alessandra Cuneo and with the presentation of the SunHorizon project. Alessandra, the floor is yours.
Thank you, Serena, and good morning, everybody. I'm Alessandra Cuneo from RINA Consulting, which is one of the largest engineering company in Italy, and I personally work within the Innovation for Energy department dealing with innovation in the energy fields related to European project. And today I will present you SunHorizon project, which is a project that I personally coordinate within H2020 project, dealing with innovative solution for covering the heating and cooling demand of buildings. So just a brief presentation of the agenda. So I will show you which are the objectives of the project and how it is structured, together with a brief presentation of the partners involved and the main innovation that each of them will perform in the project, and then to show you very preliminary results that we achieved in the last months. So starting from the project, so the aim of SunHorizon, which started more or less 1.5 years ago, is to demonstrate innovative solution to cover the heating and cooling demand of buildings, not only with innovative technologies that I will present you later in the field of heat pumps and solar panels, but also for what concern the control and monitoring aspects. So a control platform will be developed mainly by Schneider, together with other partners, to control in an optimal way the different technologies, including the direct feedback from the end users. So as anticipated before, the aim is to develop and enhance 6 already existing technologies in the field of solar panels and heat pumps, and all of the technology provider will enhance their current technologies to increase the performance and reducing the operational cost and the capital cost. And the aim is to integrate such different technologies in what we call the technology packages, which include 1 heat pump, 1 solar panel, and the thermal storage. And these 5 technology packages will be deployed and installed in 8 different demo sites around Europe to cover as much as possible a wide range of buildings, because we have, I will show you later, but in general we have residential building and tertiary buildings, quite efficient building and old buildings. So we have a very variety of buildings in which we will go to demonstrate our concept and our solution, and this will help to increase the replication potential of our innovations. Why heat pump and solar panel? Because such technologies are one of the most already accepted by the end user. They are quite common to be found in all around Europe, so this will help the engagement and the direct contribution from the end users. And of course, as anticipated to you before, the focus will be not only related to the technologies, but also from the monitoring and control aspects. So a functional monitoring data and a cloud monitoring platform will be developed during the project, and the monitoring data will be the starting point for the control strategies that will be implemented, and also for algorithms related to, for example, the proactive maintenance and the self-learning to increase and optimize as the best way the full technology package. So where we are. So the project started in October 2018, and we have just finished the 1st year and a half of the project. During these 18 months, we have the demonstration phase in which we study the technologies and understand how to integrate each other, also having preliminary results for what concern the performance of the technologies, and which could be the reduction in terms of primary energy savings and emission savings. And now we are just starting the phase of the prototype phase, so to test the different technologies and their integration at laboratory level. We are slightly in delay on that due to the COVID outbreak, but we will shortly start the laboratory test. And this test will help towards the demonstration phase that should start in September next year, to have at least 1 year of monitoring phase. Of course, so the aim is the project will finish in September 2022, and most of the SunHorizon solution that will be developed during the project should reach the market already in 1 year after the end of the project. So it's a very demonstration to market project. This is the consortium, so we cover more or less all the countries. We have a very huge involvement of industrial partners, because we have all the different technology providers. We have a huge contribution from small and medium enterprises, but of course all these partners will be supported by research institutes such as, for example, just to make some names, Cartif or SEA, that will support the technology provider toward the enhancement of their technologies. And we have associations such as the European Heat Pump Association, that is our dissemination leader. And of course, we have several associations dealing with the building sector, such as Sant Cugat and the municipality of Madrid, that are directly involved in the demonstration phase as demo site owners. The project is structured in 8 work package. We have the work package 2 that is just finished, that aim to evaluate the boundaries of our project and the demonstration strategies. And now then we have 3 parallel work packages, which have the aim to develop the SunHorizon technologies within work package 3. We have work package 4, which aim is to promote and develop a cloud-based functional monitoring platform for heating and cooling purposes, while work package 5 is related to the control aspect and the thermal comfort of the end user. Then we have the demonstration work package that involve all the demo sites of SunHorizon, and we have work package 7 related to the replicability potential and the exploitation potential of the project. Okay, so which are the technologies? As anticipated to you before, we have 3 different kinds of heat pumps. We have a hybrid heat pump that is already coupled with solar thermal panel and photovoltaic panel by BDR. We have an hybrid absorption compression cascade chiller from Fahrenheit, and we have a thermal compression heat pump from Busit. Then we have from the solar field dual sun, which will provide hybrid photovoltaic thermal panels, and we have TVP solar that will develop the high vacuum solar thermal panels for low temperature. And then we have Russia, which is the main responsible for the development of stratified thermal storage tank. And these 6 technologies will be integrated each other in 5 different technology packages, integrated different kind of technologies. So for example, technology package 1 will integrate the panels from TVP with the heat pump from Busit, while technology package 2 will integrate the solar panel from dual sun together with the Busit heat pump. And of course, the integration is based on what we would like to cover from the heating purposes, so space heating and domestic hot water demand. And in the free picture there you can find preliminary layout that we already developed for each of the demo sites. So which are the demo sites? We have 8 different demo sites with more or less all around Europe to cover different climate conditions, so from warm climate to cold climate. And we have different type of buildings, so starting from small residential buildings such as Berlin or Riga, to large residential buildings such Nuremberg, or we have social housing less Madrid, and we have different kind of tertiary buildings starting from office to sports center and swimming pool. In this way, we have a very wide range of buildings involved in the project, and this will help this will have a very high replication potential, because of course we will demonstrate that our solution could be installed in more or less all of the building stock in Europe. And as anticipated to you before, an important part of the project is related to the monitoring and control. So a monitoring platform is underdeveloped for control purposes and to define predictive maintenance strategies to reduce the operational cost of the technologies, as well as a tool will be developed to reduce the capital cost, considering the uncertainties of the different technologies, as well as a smart control and survey system is under development, starting from the monitoring data and including prediction techniques, self-learning algorithms, decision-making strategies, and user interaction. So an app is developed by CheckWhat, which is one of the partner of the project, and within thanks to this app, the end user that living within the building involved in the project will aim to give to the control their feedback on how the different technologies are controlled, and if, for example, which is their thermal comfort, and the feedback from the end user will be used for control purposes. Now I will show you very preliminary results about the simulation, the dynamic simulation that we performed to understand the performance of the technology packages for each of the demo sites. So first of all, we started from the building envelope. So starting from energy audit, we are developed a building model to evaluate the heating and cooling demand of the baseline condition, and such model have been validated with real data, starting from the energy bills of the different buildings. Then we simulate the new heating and cooling system, including very preliminary control strategies, and such dynamic simulation performed in transit as the aim to preliminary size the solar field and heat pump and the storage via parametric analysis, as well as to have preliminary results in terms of performance, in order to demonstrate that we can reach the objectives that we declare, which are relating mainly to a reduction of at least 20% of energy savings and at least 30% of emission reduction. Okay, so first of all, we developed the building envelope, including, this is the case of Nuremberg. I will show just you a case to understand you the different, to show you the different steps. Nuremberg is a large residential building in Germany. So we started with the simulation of the building envelope, considering the thermal zone and the different building characteristics in terms of internal gains, usage profiles, weather profiles, and this will help to define the baseline condition, and the baseline condition is needed to understand the performance of SunHorizon technology package. Then we started with the simulation of the technology packages, considering, of course, the single component performance. So the different technology providers provide to the consortium the map, the performance map of their technology, which are included in the models, as well as the different hydraulic layout to understand how to integrate the different technology and how to cover the heating and the space heating and the domestic hot water demand of the building. And then we aim to evaluate the technology package performance in terms of mainly primary energy savings, considering the different vector. So electricity, gas, oil, depend on the buildings and existing system, as well as the savings in terms of emission and cost. So for example, you can see that for the Nuremberg demo site, we starting from the simulation, we are aiming to reduce 32% of primary energy savings and 46% of emission. Of course, these are preliminary results of the simulation, and the models needs to be validated against the real data. So we will have a more detailed analysis as soon as we have the results from the test at the laboratory level, and then of course the monitoring data of the demonstration phase. And these are the results for Nuremberg related to the sizing, to the parametric study. So we modify, for example, the tank of the system, the number of panels, the inclination also of the different panels, and we evaluate which is the best option to so which is the optimal case for the reduction of our KPIs. And these are the results in terms of cell consumption for the electrical part, in terms of primary energy savings, emission, and operational cost for all of the demo sites. Of course, the performance level is influenced by the reference building and existing heating and cooling system, because of course some demo cases already show a very good energy efficiency performance level, while other buildings show poor ones. So that's why also we consider such 8 buildings to evaluate which is the impact considering different level of efficiency of the buildings. But in general, as you can see from the slide, we are aiming to reduce up to more or less 70% in Madrid demo case of primary energy savings, emission, and more than 80% for what concerns the operational cost. So these are very good results in terms of emission, which should have an important impact on the heating and cooling system, considering renewable technologies. So in general, this is the roadmap of the project, just to finish my presentation, which aim to demonstrate that within the end of the project, we should reach TRL 7 for all of the technology and for all the key exploitable results that we are considering and we are developing within the project. And the aim is to have more or less all of technology ready to the market in 1 year after the project end, to cover the heating and cooling demand of different kind of buildings. So we have a very wide target markets in all around Europe. So we are not focusing on just one climate or just one condition. So first of all, thank for your time. And on the slide, you can find my email address if you would like to have more detail on the project and the results that we are achieving so far.
Thank you, Alessandra, for your presentation. Now we can proceed with the third presentation that will be presented by Alessandra Insana about the project Enertun. Give me a second, and that I'm sharing with you.
Yes.
It seems that I cannot share anymore my mouse with you, Alessandra. I don't know what happened. So we can do that. Let me check again.
Yes.
Okay, we can do that. I will. You say next, and I will move your slides. Okay.
Okay. No worries.
So when you're ready, we can start.
Yeah. Okay, but I cannot see anything. Okay, good. Okay, now it works.
Sorry, now it's available. Yeah, and it's available. So I think it was like the webinar wasn't working for 30 seconds. Now you have the control, and the floor is yours.
Okay, good. Thank you very much, Serena, for your kind introduction. And thanks also to the previous speakers for their engaging presentations. So I'm Alessandra Insana. I work at Politecnico di Torino as a research fellow. I prepared this presentation in collaboration with Professor Barla, who works at Politecnico di Torino too. So I am glad to present you our work about energy tunnels as an opportunity for development for urban areas. So just a brief outline of the presentation. In case you don't know, I will explain what energy geostructures are, and then we will deepen into the topic of energy tunnels, and I will describe the experimental site that we managed to install in Turin, in Italy. And then I will try to broaden a bit our horizons with some perspectives, and I will draw the final conclusions. So, I'm sorry, I clicked twice. So energy geostructures are all those structures in contact with the ground that have a double role. So on one side, they work as a structural support, and they also have another role, which is an energy role. They work as a heat exchanger with the ground to meet the thermal demand of the buildings on top. This is a relatively new technology, quite recent. Actually, we have different types of energy geostructures, and the first types date back to the 80s with energy piles and base slabs. So we still don't know much about their performance. So it is important to evaluate how much heat we can effectively exchange with the ground and what are the key parameters that play a key role on the heat transfer processes. Here you see a picture, an example of pipes that are embedded within the structural elements in contact with the ground, and to exchange heat with the surrounding ground. So the three main types of energy geostructures are reported here. So we have piles. As I said, this is the oldest type of energy geostructure and also the most common. Then we have walls. So you see here an example of an excavation where the boundaries of the excavations, the walls, are equipped with pipes, and an example of a steel cage which is being equipped. And tunnels, this is the most recent type of energy geostructure. You see here a picture from our experimental site in Turin with the steel cage in the precast concrete plant equipped with the pipes. This is called segment. This is a piece that forms the support lining of the tunnel in case the tunnel is excavated mechanically, so using machines that are called TBM, so tunnel boring machines. Just to give you an idea of the evolution over time and in space of these structures, here I took these pictures from a reference by our research group. So on the left, we see the cumulative number of installations over time. And we see that the technology knew a great spread between 2003 and 2011, and that most of the installations are represented by energy piles. Then energy walls started to appear later, and energy tunnels more recently. About the distribution in space, we see that Austria, United Kingdom, and Germany are the countries where this technology is more spread. In particular, Austria is the country where it was born, even though here the authors say that some data might be missing from installations in France and in Switzerland. They also collected data about carbon dioxide emissions savings, or computed them when not available. We see here this figure, 1.5 million tons. So this shows the great environmental benefits provided by this technology. Okay, it's a bit, there is some delay. Okay, let's focus on tunnels now. Tunnels are particularly advantageous because we have a very large surface in contact with the ground for heat exchange, and they can be used for several purposes, such as, of course, for buildings heating and cooling, but also for the icing of tunnel portals, of bridge decks, platforms. So in this chart on the left, I show the exchanged heat for some installations, which are also real installations that are also reported in this slide. These are all the real installations existing all around the world. So we see that in terms of watts per square meter, in average, we are between 10 and 25 with some exceptions. And the installations can be found basically in Germany, Austria, China, Japan, South Korea, and now also in Italy. For example, in Japan, in Nanaori-Toje Tunnel, here you see a thermal picture at the entrance at the portal of the tunnel, where they placed horizontal heat exchangers to de-ice the tunnel portals and prevent it from freezing to avoid winter accidents. In Vienna, Jenbach Tunnel had the aim to heat the nearby city council, or in Linchang Tunnel, they wanted to heat the lining to prevent it from being damaged by cold temperatures. Okay, what are the steps needed for energy tunnels design? First, we have steps of characterization. So in terms of hydrogeology and stratigraphy of the ground. So we're interested in understanding, for example, the direction of the groundwater flow and its velocity. Then we also want to know what's the temperature of the undisturbed ground and its thermal conductivity, for example, so the thermal parameters that are involved in heat transfer processes. So this can be done by performing in situ tests, such as the thermal response tests that were also mentioned by Eduardo, or laboratory tests, and in the preliminary stages of the design, also thanks to literature analysis. Then we have thermal design, which means how much heat can we exchange, what are the effects in the long term on the surrounding environment, and this can be done basically by means of numerical modeling or by simplified tools. And finally, but this will not be the focus of this presentation, the structural design, because we don't have to forget that heating and cooling cycles can have an effect on the lining, so on the tunnel support, which is made of concrete, and so we don't want it to be jeopardized by the thermal activation of the tunnels. Now, at Politecnico di Torino, we developed recently a patent called Enertun, which is an improved energy tunnel segmental lining that basically optimizes heat exchange compared to previous configurations, because it changed the layout of the pipes, which are oriented in this direction, so in the hoop circumferential direction. There is an increase of performance compared to previous configurations. You can see it on this chart. When there is no groundwater flow, the performance is the same, but there is an increase in 10% when the groundwater flow is perpendicular to the tunnel axis. There are 3 possible configurations depending on the aim. So we have the ground configuration, where the circuit is placed closer to the ground side, so closer to the extrados, or closer to the intrados in the air configuration, which could be used, for example, in alpine tunnels to reduce tunnel inner overheating and to reduce ventilation costs. Or we can endorse both circuits. Now, in Torino, thanks to a proof of concept funding, we were able to install a full-scale prototype of the Enertun ground and air configuration. So you see here a map of Turin Metro Line 1 with this dashed section here from Benghazi to Lingotto Station, which was under construction. It is still under construction, actually. And the experimental site was installed here, close to Benghazi Station. We equipped 2 rings. So the total longitudinal length is 2.8 meters. You see here on the right a cross-section view in the area of the experimental site. The tunnel is completely below the groundwater table. This is the groundwater table, and we have a strong groundwater flow from west towards east, so towards the river Po. This is a particularly advantageous aspect because it allows to thermally recharge the ground, the geothermal reservoir, and so to have a constant performance over time. Here, a plan view of the station. So this is the station. We have the entrance, and the energy rings were installed about 40 meters northwards from the station. We see a picture in detail A. We have these 2 are the 2 energy rings. These pipes on this side allow to connect the energy rings to a space here where the future elevator will be located, where we have the heat pump, the data logger, and a fan coil to exchange heat with the air, so there were no real end users benefiting from this system. Okay, as this was an experimental site, it was extensively monitored. So here we were in the precast concrete plant where the segments are fabricated. You see the 2 nets of pipes with which we equip the segments. And some sensors. So for example, this is called pressure cell, and it allows to measure stresses inside the lining. These are fiber optic sensors to measure strains and temperatures. We have these objects here that we called pockets. So they allow the pipes to exit the segments, and this will allow for the connection in situ to the nearby segment in order to obtain a continuous circuit. And then also some strain gauges, again, to measure strains and temperature. So let's see an example of a test that we performed. So in winter mode, for example, during each test, we turned on the heat pump and we set the temperature, the return temperature on the secondary circuit side, so the circuit of the user. Here it was set at 45 degrees. The test lasted 8 days. Okay. And once we turn on the heat pump, we see that this curve in blue is the temperature exiting it and going towards the energy rings, while the red one is the one that comes back from the rings. The gray and black curves are the air temperature measured in different locations inside and outside the tunnel. They're very similar between them. And these two curves on top are the inlet and outlet temperature from the secondary circuit. In this thermal picture that we took during the test, we can identify the two rings in operation, given that they have a lower temperature compared to the conventional rings adjacent to them. So from the difference of temperature between the inlet and the outlet temperature, we could estimate the specific power per meter of tunnel length, which amounts at about 1 megawatt per kilometer of tunnel. So what does it mean? That an energy ring installed in Torino in winter would allow to heat about 23 buildings, where each building has 5 floors and 4 apartments per floor. We also estimated the payback time, which is about 7 years. Now, currently the experimental site was dismantled last year because we had to allow the works in the construction site. But we are currently working to reinstalling it and making it permanent also during the operation of the metro tunnel. This is because we have noticed, and this is also written in literature, that we have an influence of air temperature on the thermal performance. And so we expect the tunnel climate to be different during the operation of the tunnel. So we would like to investigate that. And here there is the configuration that we imagine. So this is a layer of concrete where we have some holes, which we can see here, in which the pipes would go through. They would reach the heat pump in this environment below the platforms. And it will be then connected again to a fan coil to heat and cool the station. So if any heat pump manufacturer is interested in testing their heat pump, well, they're welcome. And about the perspectives, as a tunnel in a urban environment runs for several kilometers, such as in this figure here, there will be some points such as stations or ventilation shafts that connect the underground with the topographic surface. We imagine that from this point we could have a local distribution network of heat so that the tunnel could work as a district heating and cooling system at low temperature. So to conclude, I hope in this presentation to have shown you the good geothermal potential of energy tunnels. We have identified the design aspects concerning both the thermal and the structural design. Here we focus more on the thermal part. We have quantified, thanks to the experimental site, the thermal performance amounting at 1.1 megawatt per kilometer. And now we should go from the prototype to a full metro line equipped with energy rings. So this is the challenge for the future for developing cities. So thank you for listening. Here you can find our contacts in case you have doubts or you're curious about more aspects. So thank you.
Thank you, Alessandra, for your interesting presentation. Now we can proceed with the last presentation made by Dan Stefanica from EHPA. I would like to remind to all the participants to use the chat box for any of your questions or comments. Then I'll make you the presenter. So the floor is yours whenever you're ready.
Thank you so much, Serena. And it's very nice to see all the presentations that preceded me, very interesting ones. And to be honest, we are very glad to be partners in 2 of the projects. So my name is Dan Stefanica. I'm the project manager at EHPA at the projects team. Well, you know a lot about EHPA. I will not go into that. But you may want to know more about the projects team. So basically, Serena, my colleague, is part of the projects team as well. We are currently running 7 projects, 6 Horizon 2020 projects. One of them is SunHorizon that Alessandra very nicely showcased. One of them is Interreg, and which Eduardo very nicely showcased as well. With another Horizon 2020 project starting in September, as well as a tender relating to heating and cooling. What I will present about will be basically another project that we are part of called the Renewable Heating and Cooling Platform. The internal initiative of EHPA called the Research and Innovation Committee. Then all the parts associated with these 2 initiatives that you, the participant of this webinar, and a relevant stakeholder can actually participate in, as well as how do we connect this RHC work that we're doing along with our partners with the research and innovation aspect, mainly relating to heat pumps. So just very quickly, what is the RHC platform? Well, since 2016, the RHC platform is a European technology and innovation platform. It basically showcases that renewable energy technologies for heating and cooling are not only safe, clean, efficient, increasingly cost-effective, but they're already available for use. We have so many partners, so many projects and experts, all saying the same things, all basically contributing to the energy transition. We're always trying to combine and improve the technologies that exist, to bring experts together, to discuss the way forward in policy, in funding, in pilot projects. And I strongly encourage you to access the website of RHC, where you can find a lot more information about it. Now, a few goals related to the RHC platform. As you can see on the screen, basically developing working relationships with other relevant national and regional platforms. As an example, the Z Plan, working group number 5 of the Z Plan, the upcoming Horizon Europe partnerships, the one called Build for People, the clean energy transition one, the one in urban renovations and urban restructuring. So we're always on the lookout of how we can establish synergies with other platforms. So our message is even more established and disseminated. Establishing and updating the strategic research and innovation agendas per technology area that we will go into further in the next slides. Identify priorities that are cross-cutting of nature, so that are applying to heat pumps, are applying to district heating, are applying to solar heating and so on. So, for example, education and training or international cooperation. As well as identifying what are the barriers to innovation, notably the ones related to regulation and financing. And this you can find in the form of very informative deliverables that are already done or already almost completed. For example, a deliverable about financing in almost all of the European Union that you can just very easily find what is the financing available for installing a heat pump, for example. And reporting on the implementation of research and innovation activities at the European, national and industrial level. Now, what are the documents that we are preparing? The main documents, I would call them. Well, basically would be the macro overview planning. This is represented by the vision that we prepared, the vision to 2050 for 100 renewable heating and cooling in Europe. Technology implementation, and that you can already find on the website and it's completed. we are now working for the strategic research and innovation agenda and setting them up for the different technologies that make up RHC. So, for example, the strategic research and innovation agenda for heat pumps or buildings or cities. So we are progressing in that, and then after completing this, it will be another main document relating to concrete actions that we need to achieve so we can make the vision and the strategic research and innovation agenda a reality. Because the vision is already completed, you can already find it on the website. As you can see, it has chapters relating to the technologies of renewable heating and cooling and work being done by us and our partners. So solar thermal, biomass, geothermal, heat pumps, thermal energy storage, as well as district heating and cooling. And again, I strongly encourage you to take a look. Something very useful is also, and you can see this on the website, is that we're also developing a projects database, an RAC projects database that captures all the projects that have a renewable heating and cooling aspect to them. So if a project includes a heat pump or includes a district heating in all sorts of TRLs, you are more than welcome to share this on our website, as well as making it available to all of the relevant stakeholders that are actually using our database. So it's basically a one-stop shop with a user-friendly interface that can be easily sorted and continually added upon. And you can see here a picture of how the database looks like, as well as how you can sort it. So by area of application, by technology, by the solution used, as well as other filters that are available on the website. So again, if you're looking for a project or projects that deal with renewable heating and cooling, you now have a way of easily sorting them and finding them using the RHC platform. You can also become a member of the platform. Basically, this gives you access to for you to contribute to these papers that I talked about, to participate in the events, to have your voice heard at the policy level, to network with the other experts that we have, and also it's very important to us to have as many experts as possible, so we would have a complete picture of where the technology is, where the technology needs to go, and what are the barriers and how are we going to solve them, so we can achieve the vision that we set up for the future. I also want to invite you to the event that will happen with the platform. It's going to be online due to current circumstances on the 15th of October 2020. And the agenda is already available, and I really encourage you to check the information on our website and register. Again, it's quite interesting, and it will go into the strategic research and innovation agenda. It will have a national roundtable where policymakers from Lithuania will come and discuss the specific challenges that Lithuania faces in the deployment of renewable heating and cooling. So quite an interesting event overall. Then a bit about the EHPA Research and Innovation Committee that I am the chair of. Basically, EHPA has a lot of committees and task forces. A committee example for EHPA would be the Manufacturers Committee, where heat pump manufacturers come and discuss the issues and the innovations relevant to them. A task force would be the one related to eco-design. These are just open to members of EHPA. However, the Research and Innovation Committee is open to all relevant stakeholders. This is because we want to include as many relevant stakeholders as possible. Firstly, so that we can have a clear view of the research and innovation needed in our field, as well as establishing as well as optimally establishing faster consortiums related to Horizon 2020 tenders, and any other initiative applications. So this, again, this is open to everyone that is a relevant stakeholder. We meet 3 or 4 times per year. The meetings are online, and they are coupled with other events, for example, the drafting of the RHC documents that we just touched upon. They also deal with, again, applying to other initiatives such as Horizon Europe, tenders, and the work being done for RHC. Now, just a bit of how do we combine RHC with the renewable and RHC with the Research and Innovation Committee of EHPA. Basically, like I said, we're preparing a strategic research and innovation agenda, and in our case, we couple this with preparing a strategic research and innovation for innovation agenda for heat pumps. Now, as you can see, just an example, choosing to prepare it by the heat pump life cycle, let's call it like that. We can start with research and development that leads to policy, that leads to funding, that leads to more research and development. So basically a circle where research and development is represents demand, design, manufacturing, installation, maintenance, replacement, upgrade, and again, demand. So what is demand, for example? So we look into user perception of new buildings, renovation, industrial work, the communication strategy, the demo sites, the one-stop shops, the innovative business models, the sector coupling and flexibility. What is design in this case? So modularity, the way that the heat pump is designed to be modular, the way that its parts and itself is adhering to the circularity principles, the ease of use, the hyper efficiency, easily connected to other technologies and storage mediums, health and ergonomics. So this is just a bit of how we combine the work that is being done in our project of the Renewable Heating and Cooling Platform with the work that we do in the Research and Innovation Committee of EHPA. So this is just a small, let's say, taste of the solid work that we're doing there, and I encourage you to check both RHC as well as the Research and Innovation Committee on our website. When you will get this presentation and the follow-up package, you will have all the links available. And thank you so much. If you have any questions in the future, please don't hesitate to contact me on the email that you can see now on the screen. Thank you so much.
Thank you, Dan, for your presentations. So now we can proceed with the questions raised from the audience. We have received some, but you are still in time. If you want to send us other questions, please send it via chat. So let me open the questions. So for Alessandra Cuneo, we can start from you. You can unmute yourself. In the meantime, I will propose you the questions that we received. So, what is the ratio between energy demand, heating and cooling in the reference building? So I guess it was referred to the Nuremberg demo site.
Okay, so in general, for the project, we dealing most with the heating demand. So to cover the space heating and domestic hot water demand, the demo in which we are focused more on the cooling part is Sant Cugat, in which the Fahrenheit heat pump will be installed in the demo sites, and the main challenge here is the sizing of the heat pump cover the cooling demand, because the cooling demand is the how to say, the main important contribution for the Sant Cugat building. So the problem here is to sizing the heat pump to cover the cooling demand of Sant Cugat, but in order that it is not too oversized for the heating demand. So if you would like to have a sort of percentage between cooling demand and heating demand in Sant Cugat, because for Norberg we are going to satisfy only the heating one, the cooling demand is more or less 2 times higher respect to the heating one.
Thank you, Alessandra. We have another question for you, which is the feedback from the end users about the SunHorizon technologies, and what do you think could be the barriers to overcome this active engagement with them?
Okay, so for the moment, the end users has been involved in the preliminary phase. So the different demo owner is in close contact with the tenant to in showing the objective of the project and how we are going to integrate our heating and cooling system in their buildings. And this part of the work is mainly related to the residential one, because the tenant will be directly involved in this phase, and also inform them that because during the project we are going to install several sensors within the buildings to evaluate the air quality, the temperature of the different rooms, the presence of the tenant in the different rooms, to manage the technologies. So there is a lot of work on that side to inform them and to let them aware of the data that we are going to collect from their habits and how we are going to manage such data, etc. And in general, there is a good feedback from the end users, but we will see during the demonstration phase, because it's the main part of the project. The main challenge that we are facing is to get them aware that they are most worried on to change their habits. So they are worried that due to the new heating and cooling system, and that such system will be directly controlled by our control platform, they cannot modify anything more about the temperature of the rooms or the set point of their heating system. So even if the technology are quite accepted and quite common in the heating field, the main concern is how we are going to modify their habits and their current thermal comfort of the building. So a lot of work is needed to get them aware that they continues to live in their houses without not much impact on their current habits.
Thank you, Alessandra. Now we can go to Dan, because we received a few questions for you. So then one question is about the renewable heating cooling platform. So they are asking which platforms are available at RHC for industrial scale heat pumps, and if Switzerland is covered.
Yeah, so thank you for the question. Basically, we have a group where EHPA is vice chairing, and this is the industries horizontal working group. We have, I think, Swiss stakeholders. However, if the person that asked the question is still present, we can talk afterwards. And if you are interested in collaborating, we would be very interested. So please get in contact with me using the email in my presentation, and let's discuss it.
Then one question for you then, this is about the Research and Innovation Committee. So what is the procedure if some of the attendees or other external stakeholders want to be part of the committee and participate with EHPA in some project proposals?
Yeah, so thank you to whomever asked that. So there are two parts to this question. One is if you're interested in the Research and Innovation Committee, we are as well interested in you. As you are in this webinar, you're probably a relevant stakeholder benefiting from a lot of expertise. So we would welcome your expertise and participation. All you have to do is basically just write me an email because you may want further information about it. And then you just write me an email with your expertise. What would you like to get out of this committee? What would you be interested in contributing towards its work? And then we can discuss it. And we will meet. The next meeting will be on the 4th of November, and we would be very much welcoming anyone interested in this initiative. The second part of the question relating to projects, basically, we are interested in all the projects that involve heat pumps. Just looking at the calls that are in September, just for Horizon 2020, there are about 14 interesting calls that we can participate in. We've already started to assemble consortiums in some of them. If you would want to be a partner, again, just email me. If you don't know exactly what the calls are, no problem. We have an Excel database, let's say, so you can see what the calls are. If you are the coordinator, again, just contact us and we will set a meeting with you in the next, I would say next week or in the next weeks as the deadline is upcoming. And we would see what we can do, if we can participate. If not, we will probably know somebody that would want to participate. So basically, it's a win-win. You just have to get in touch with us. And I would add that even if you have something, because I've already received some emails with questions, even if you have something not related to REC projects or the Research and Innovation Committee, but you think would be relevant to our work, again, please don't hesitate to contact us. Even if we don't know, we may know somebody that is interested. So thank you so much for the question.
Thank you, Dan. Now I have some questions for Alessandra Insana. So we received this comment for you, that is, if you are aware of energy sheet piles, which are part of the category or the wall category that you showcase in your presentation.
Yes, they are another type of energy geostructures belonging to the energy piles. Then it's a particular kind of piles. We also have other types like flight auger piles. In my research, personally, I'm not focusing on piles, but yes, they exist, as I showed you in the picture where there were the three types of energy geostructures, so piles, walls, and tunnels. We focused on tunnels because it was, in terms of research, it was the least developed kind of energy geostructures. But of course, that's another possibility.
And I have another comment/question for you. That is, yes. That it says about the perspectives of such system that you presented, the district scale. Were you already involved in any other projects, or did you perform any other study?
Yes, we were lucky to take part to a project here in Turin, because currently the Turin Metro Line 2 is being designed. So we took part in the feasibility study for that pertaining to the estimation of geothermal potential of the geostructures along the line. So the tunnel structures, both excavated by means of tunnel boring machine or by means of other techniques called cut and cover technique. And we developed a methodological approach to deal with the estimation of geothermal potential along the wall line. Basically, we identified the key parameters in heat transfer processes, and we divided the line into sections, and then we grouped the sections characterized by the same set of parameters. So it was possible, thanks to numerical modeling, to estimate for each homogeneous section the heating and cooling potential. There, the interest was to we were asked was to estimate, to match the thermal demand of the stations, both in summer and in winter. And what we obtained was that for most of the stations, just one or two, now I don't remember exactly, the thermal demand of one or two stations could not be met, but for all the others, we would be able to cover, to fulfill the demand, and there would be an excess of heat that could be delivered to buildings on top. So that was an interesting application at the district scale. Then we also collaborated with a multi-utility here in Italy, which is called EREN, that manages the district heating and cooling system. They were interested in understanding whether it would be possible to integrate this low temperature resource into a district heating and cooling system. So these are the two main projects we worked on.
Thank you, Alessandra. Now we can proceed with the last question, because our time slot is ending. So I have one question for Eduardo Rodriguez, and a request of clarification on what type of training did you develop in the framework of the GeoAtlantic project?
Okay, thank you for the question. As I said during my presentation, we elaborated specific geothermal energy training for 5 different agents. In the case of decision makers and technicians from local administration, we prepared a specific documentation about what are the administration steps to legalize a geothermal facility. In the case of energy prescribers, architects, engineers, etc., and small and medium enterprises, we prepared the specific technical documentation of main components of geothermal facilities, how to calculate them, and also including economic analysis of technological with respect to conventional system. And finally, for the neighborhood association, we prepared a document about general benefits related to geothermal energy and how they could access to it. I don't want to forget that outside of the Work Package 5, Ourense Council also prepare some training for kids, in which the leader of the project explain them what is the geothermal energy in a funny way. And to finish, I want to say that all the documentation that I showed to you is available in the GeoAtlantic website.
Thank you very much. So now it's noon o'clock, so we're already really on time. I would like to thank you all the participants and the speakers for the really interesting presentations. I would like to remind you that tomorrow you will receive all the presentations and the video. If you have any further questions for the speakers, because we couldn't answer to all of them now during this session, you have their emails, so I think they will be really glad to answer to all your queries. Plus, you can check all the project's website, and I'm sure you will find some information also in there. So thank you very much. And don't forget that if you are interested in these projects online talks, check out the EHPA website for the further events. Thank you and have a nice day.
Have a nice day, everyone.
Thank you.
Thank you.
Thank you.
Have a nice day.
Have a nice day. Bye.